Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 10 from the June 2020 C34 EdXL International A-level paper, which is, this particular topic is about solving differential equations, and this is a part of the P4 in the new specification. So this question here tells you about this vertical cylindrical tank of height 225 centimeters containing a liquid. The liquid is leaking out of a hole P at the base of the tank. At time t minutes after the leaking starts, the height of the liquid in the tank is h centimeters. The rate at which the height of the liquid in the tank is decreasing at any time t is in minutes, is modeled as being proportional to the square root of the height of the liquid in the tank. So it's proportional to the square root of the height of the liquid in the tank, the rate at which the liquid in the tank is decreasing. They've also told us when t equals 0, the height of the tank is 225 centimeters, as we can see from this. And when t equals 125, the height of the water in the tank is 100. It says the liquid stops leaking from the tank when the height of the water is 0. Alright, so it says by forming and solving a differential equation, show that the model leads to this equation: h equals 15 minus 0.04 t all squared, and t is between 0 and a, stating the value of the constant a. Alright, so now I've got the information I need, or some of it, over here, the beginning of the information, and we'll continue the next page, but basically we're going to just start off here. So it says the rate at which the height of the liquid in the tank is decreasing. Okay, so the rate of increase, or the rate of decrease, the rate of change of the height with respect to time, any time t minutes, is dh dt. That's the rate of change of the height. Now the height is changing in such a way that it's decreasing. So it's minus proportional to the square root of the height of the liquid in the tank. So it's basically, if it's proportional to something, it's equal to a constant times that thing. Okay, it's equal to a constant times that thing. So dh dt is minus k times the square root of the height of the water in the tank. Okay, so this is the basic differential equation that we've set up, that from the information given, that the rate of decrease of the water in the tank is directly proportional to the square root of the height of the liquid in the tank. So it's equal to minus y, because it's decreasing, it's a negative, minus k times the square root of h. Okay, k because it's proportional, the constant of proportionality. All right, so that's how we've set up the differential equation. Now we have to show that this becomes that with the information given. So I've kind of set it up in the next page for us to continue. So this is what we have so far. All right, so now we've got to show with this information here that that's what we're going to get. So we have to basically solve this differential equation. When you solve a differential equation, okay, you get rid of the, here, in this case, the dh dt. Okay, this is a differential equation because it has a, a rate of change in it, like dh dt or dy dx or dx dt or whatever it is. This is dh dt. We have to get rid of this and make it as h in terms of t. Okay, so we have to basically do the following. To solve a differential equation, you have to integrate both sides of the equation with respect to, like in here's dh dt, here with respect to t. So dh dt integrated with respect to t. What I do to one side of the equation, I do the same to the other. This is how I like to start off my work with differential equations. Minus k times root h dt. So I'm integrating both sides with respect to t. Okay, I'm going to start off like this. Now this cancels with that. So I've got the integral of dh equals the integral of, I'm going to take the k, the constant, it's just a constant, so I'm going to take it outside. I always like to write it outside. I'll put minus k times the integral of, I'll call this h to the power of a half dt. Now when you are going to now integrate this, you have to make sure that on the side which has a particular differential letter like dh, you have to have the h's. On the side that has dt, you have to have the t's. Now you have h to the power of a half here. If I divide both sides by h to the power of half. I'll have here 1 over h to the power of a half, which is h to the power of negative a half, getting it ready to integrate. So this is h to the power of a half, integrating with respect to h, equals minus k times the integral of, well, it's just 1 times dt. Okay, 1 dt. So now I can integrate this. Okay, what I'm going to do here is I'm going to integrate it, and I'm going to put some limits in after I've integrated. I'm going to use these limits here, and I'm going to first find what k is. Now, there's different ways of dealing with this. Okay, I'm going to use limits here. Once I've integrated it, I'm going to put some limits in. Okay, you can also integrate it and put plus c and then work out what c is. I personally prefer using this method I'm going to show you now. So to integrate this, you have to add 1 to the power, so it's h to the power of a half, divide by the new power, so divided by a half, equals, and if I integrate this, I'll have minus k times, now this I'm going to, this becomes just t. Now I'm going to put some limits in here, because I'm going to find what k is first. So to find what k is, I'm going to use, when t is 0, h is 225, and when t is 125, h is 100. So I'm going to use these limits here. So I know that I'm going to put, for example, over here, I'll put the ones that are related to each other. So I put when t is 0, h is, whoops, sorry, t is over here. When t is 0, h is 225. And when t is 125, h is 100. I can put them any way I want. I mean, as long as 100 and the 125 are in the same place, and these are at the same place, in the end it will work out correct. So I'm going to use these limits now. So I'll have 225 and 100 and 0 and 125. And that will help me find the value of k. Okay, so now this, let me just simplify this. It becomes 2 times the square root of h, and the limits are 225 and 100, because divided by half means multiplied by 2. I'll write the 2 outside here, equals minus k times, and here I'm going to have, I can put the values in, 0 minus 125. So here I'm going to have 2 times, this is going to be the square root of 125 minus the square root of 100, equals, and I have minus k times minus 125, which is 125 times k. So this gives me 125 times k. So this is 2 times, this is 225. Excuse me there. The square root of 225 is 15, so that's 15 minus 10, and that's 125 times k. So that's 2 times 5, which is 10, equals 125k. Therefore, k is equal to 10 divided by 125, which is going to be, if you divide by 5, 2 over 25. So 2 over 25, I think 0.0, what's that going to be? Times 4 times 0.08, I think. Let's just make sure of that. So I've got 10 divided by 125. 0.08, that's right. So that's the value of k. All right, so now I've got the value of k. Now I can continue this. So what I'm going to do now is I'm going to go back to the same place here where I put these limits. So I have 2 times the square root of h, okay, equals, now I know what k, so minus 0.08 times t. But I'm going to put the limits in now so I can find h in terms of t. So I could use either of these, okay? So I can put here h on top, and I can put t on top. And then I can put, for example, here 0, and I can put here 225. And that should give me the equation that I need. Okay, so let's see what happens here. I have 2 times, this is the square root of h, so 2 times the square root of h minus the square root of 225 equals minus 0.08 times t. Okay, I can divide both sides by t, so I'll have the square root of h is equal to minus 0.04, divide both sides by 2, sorry, 0.04 t, and this is going to give me 15. I add 15 to both sides, it'd be plus 15. So I'm left with, I'm almost there. Let me just, can this go? Okay, I'll go from here to there. I've got just a little bit of space left here. So now I can square both sides. So I have h equals, you can say 15 minus 0.04 times t squared, which is exactly what I had to show. Okay, 15 minus 0.04 t all squared, 0.04 t squared, sorry, and that's exactly what I have to show. Now I have to find the value of a. So I'm going to do that over here. I'll just make a little bit of space here to find the value of a. So I've shown what I've had to show in terms of what h is. So there's my answer. Okay, now I've got to find what a is, because we know that t has a limit between 0 and a. Okay, now we know that t is equal to a when h is equal to 0. Okay, when h becomes 0, that's when you're going to reach, the maximum time, when it becomes, the time for it to empty out. It empties out when h is 0. So if I take the equation we just formed, okay, and I put h as 0, so I say 0 equals 15 minus 0.04 t all squared. I can take the square root of both sides, in which case 0 equals 15 minus 0.04 times t. I can then rearrange this equation. 0.04 t equals 15. So t is equal to 15 divided by 0.04. So t is equal to, so you have 15 divided by 0.04, which gives you 375 seconds. Okay, so we can say, it says stating the value of the constant a, so we can say therefore a is equal to 375 seconds. So we've stated the value of a, and there's the answer to the to this particular question. So we solved this this differential equation, and we did it in a way that might be a bit different than what maybe you're used to. I like to use the limits all the way rather than finding what plus c is, or writing plus c and then finding the value of c. I prefer to use limits right from the beginning. So over here, I've used limits as well. Well, I've already put the limits in there. Okay, yeah, so I use limits. So first of all, I tried to find what k is. So I found what k is by using both of these limits. So it says when h is 225, t is 0, and when h is 100, t is 125. So I used those limits, and that helped me find what k is. And then I went back to my expression where I integrated it, okay, which is basically this, and I know the value of k, so I put minus instead of k. I put 0.08, and then I could use either of these two limits. I could use these two limits together or those two limits together, and I would still get the same answer. Okay, it really doesn't matter which one I do. And in fact, I'm going to just show you. I'll make some space down here. I'll show you what happens if I used the other set of limits instead. So let me just take this down here. Whoops, just to show you how this works. Supposing I decided to go back to my expression where I integrated. I have 2 times root h. I got minus 0.08. I found what k is now, times t. And then I use, instead of using 0 and 2, so I'm going to put h and t because I want to find h in terms of t. So I have to put h and t on top. Then I use these two the first time. Let me use these two and show we get the same answer. So instead of h, in the h part, I'll put 100, and what corresponds to that time is 125. Okay, so now let me put this in. So I'm going to divide by 2 first. So I'll divide by 2, so this becomes minus 0.04, just divided by 2. Okay, I just did that first. So this is going to be root h minus root 100 equals minus 0.04 times t minus 125. So I'll have root h, that's going to be 10, equals minus 0.04 times plus, that's going to be plus, this times that gives you 0.04 times 125. 125 multiplied by 0.04, whoops, that gives you 5. That's going to be plus 5, and plus 10. Why? Because minus root 100 gives you minus 10, add 10 to both sides. So I end up, this is a t here, sorry. Supposed to be a t here. So I end up with the square root of h is equal to 15 minus 0.04t. So h is equal to 15 minus 0.04t to the power of 2, which is exactly the same as what we got. So it doesn't matter which pair of the values that we used. Okay, I could use this pair or that pair. Whichever one I used, I end up with the right answer. So first I use both of them. I used both pairs to find what k was. That's what I did first. Okay, so that's what I did here. That helped me find what k is. Once I found what k is, I went back to what I integrated. I went back to this stage here, and then I used this and just made h and t on top because I want to find h in terms of t, and then just use one pair of values that I know, both values at the same time. When h is 225, that's when t is 0, or when h is 100, t is 125. And both of them give me the same equation in the end. Okay, so there's the answer to part A of this question. Okay, I went on a bit for this question just to explain. All right, sometimes the time of the videos is really long, but it's because I like to take time to explain some of the details rather than just rush through and just be like a talking mark scheme. I don't want to be just a talking mark scheme. I want to be able to explain for those students who don't, understand the mark scheme. All right, so now part B. It says find, according to the model, this model we just proved, the time taken for the height of the liquid in the tank to decrease from 100 centimeters to 50 centimeters, giving your answer to the nearest minute. So what we have to do first, let's make time the subject of this. So I start off with h equals 15 minus 0.04t, all of that is squared. So I'm going to take the square root of both sides, so I'll say the square root of h is 15 minus 0.04t. Let's now bring this in the positive side, add this to both sides. So I've added 0.04t to both sides and taking away the square root of h from both sides, and then I'm going to divide both sides by 0.04. So t equals 15 minus the square root of h divided by 0.04. Now we want to find the time between it's decreasing from 100 centimeters to 50 centimeters. So let's find out what the time is when the height has reduced to 100 centimeters. So when for the time for it to reach 100 centimeters is going to be 15 minus the square root of 100 over 0.04. So that gives us 15 minus 10 divided by 0.04. Square root of 100 is 10, of course. 0.04. That gives us 125 seconds. Okay, that's 125 seconds for it to reach 100 centimeters. And we want to find the time for it to reach, the height to reach, what was it? 50 centimeters. Okay, 50 centimeters. So let's see, the time for it to reach 50 centimeters is going to be 15 minus the square root of 50 over 0.04. So let's just put that into the calculator, just 15 minus, change that to the square root of 50. That's not an exact value, square root of 50. And that gives us 198.2233. 198.2233 seconds. Therefore, the time it takes between the time, how do they word the question? The time taken for the height to decrease from time taken for h to decrease from 100 centimeters to 50 centimeters is equal to 198.2233 minus 125. So you take this value, you take away from it 125, and that gives you 73.2233 seconds. 73.2233 seconds. They want us to round it to the nearest, sorry, it's not seconds, it's minutes. We're talking about these are in minutes, not in seconds. Excuse me. These are all minutes. These are minutes. Minutes. What am I doing? Excuse me there. All the time I said minutes, I meant seconds, I said minutes. This is in minutes. Okay, so that's 73 minutes to the nearest minute. So there's the answer. Okay, so it's in minutes, as I mentioned. Now, all right. So there we have the answer to question part B. Let me just make sure. I think I read it in the beginning. In the first part of the question, it said T is in minutes. So yeah. Okay, so you have to be careful not to mess that one up. Okay, so there's the answer, 73 minutes, and that concludes this question, I think. Yep, that's the end of this question, parts A and B. I hope that was clear. This was a typical differential equation type of question. Other questions you might want to see from this paper will be in this playlist that should appear in this area. The link will be here. The link for questions about differential equations and integration in general will be found in these two places. And you can subscribe to my channel by clicking on this link. Thank you for watching and see you soon.